Enter GraphQL, a query language designed to make these tasks more streamlined and efficient. At the heart of GraphQL are queries. These are not just requests for data, they are precise specifications of what you need. For example, consider the following query. This query fetches the name and email of a user with the ID 1, as well as the title of their posts and the text of comments on those posts. What's powerful here is the ability to fetch all this data in a single request. Fields in GraphQL are the building blocks. They define the pieces of data your query will retrieve. You can also use arguments to filter results, like fetching a post with a specific ID. Aliases help in fetching data for multiple users simultaneously, without mixing up the results. Fragments in GraphQL help in reducing redundancy by allowing you to create a set of fields you want to reuse. Variables add dynamic capabilities to your queries, making them reusable by allowing you to pass in different values. Directives further refine GraphQL's capability by controlling what data is included or skipped based on conditions. Mutations are used for changes on the server, such as creating a new user. Subscriptions keep you informed about real-time updates as they happen.
Consider a scenario where you need to fetch a specific user's details, their emails, and a limited number of their posts, along with the comments on those posts. Here's how you would construct your query. Start with a simple query block. You write user ID 1. In this query is how you specify that you want to fetch the user with the ID of 1. This is an example of a query with arguments. Next, you include, and these are straightforward, they tell GraphQL to fetch the name and email fields of this user. The part is more interesting. Here you're asking for the first 5 posts of the user. This demonstrates how GraphQL allows you to limit the data you retrieve, enhancing query efficiency. Within each post, you request the, and then dive deeper to fetch comments. Each comments and the are specified, showing GraphQL's capability to handle nested data fetching effectively. Now let's shift gears to mutations, which are used to modify server-side data. Suppose you want to create a new post. Your mutation might look like this. Mutation create post, $input create post input, create post input $input. Here is a function call that passes user-defined inputs to the server. This mutation will return the and of the newly created post, demonstrating GraphQL's use in both fetching and manipulating data. For real-time data updates, GraphQL offers subscriptions. For instance, subscription on post added title subscribes to events related to the addition of posts. Whenever a post is added, this subscription fetches the and of the post, illustrating GraphQL's ability to handle real-time data. Lastly, consider a complex query involving conditional data fetching. Query getUser, $userid ID, $with posts, Boolean, user ID, $userid, user fields, fragment user fields on user, name email posts include if $with posts, title comments, text. Here is a fragment, a reusable component that defines fields to be fetched. The directive conditionally fetches posts, demonstrating GraphQL's flexibility in dynamic query scenarios. In summary, GraphQL transforms the way applications retrieve data. By allowing precise query specifications, efficient data fetching, and real-time updates, GraphQL not only reduces the bandwidth, but also enhances the overall performance of web applications. As developers continue to seek optimal solutions for data management, understanding and utilizing GraphQL's full potential becomes increasingly important.